All right, let's take a look at some inequalities and interval notation. Okay, so we're going to compare a simple inequality. We're going to look at the set builder notation. We're going to look at what it means on a number line. And then finally, we're going to write it in interval notation as well. Okay, so these are 4 different ways that we can express the same values. Okay, so let's look at an inequality. Let's say we have x less than 5. Okay, so this means numbers that are less than 5, but not including 5. Okay, because if it was including 5, it would have to have the equals underneath it. So this is strictly less than 5. Writing this in set builder notation is almost the same. Okay, remember our set builder notation, the set of all x such that, and then we put the condition in here, x less than 5. Okay, and then on a number line, there's 2 different ways to draw this. I'm going to draw both just in case you've seen either of them before, but the book's going to use the top notation. So we could fill in all the numbers, but the one that we're really interested in is 5. Okay, so you can fill in the rest of the numbers if you want. All right, so we want all of the numbers up to 5, but not including 5. So we can't stop at 4 because we also need like 4.5, 4.9, 4.9999999. So we have to have some way to symbolize that we've got everything up to 5, but not including 5. Okay, so we want this part of the number line, all the numbers that are less than 5. Okay, and then we need a notation for what happens at 5. So there's 2 different ways that you can do this. You can use a round bracket. Okay, and it opens towards the direction of the shading, or you can use an open dot. Okay, both of those things tell you that 5 is not included. The top one is the one that the book uses, and that's the one that we're going to use, but I'm going to put the open dot version below it just in case that's what you're familiar with so you can see how they compare. Okay, so this is what it looks like on a number line. All the numbers less than 5, but not including 5. All right, now to write this in interval notation, we always go from left to right. Okay, on the left end of the number line is negative infinity, on the right end is positive infinity, and we're going to read what numbers we have, the part that's shaded. So we start at negative infinity, we're shaded. We're going to go negative infinity to positive 5. So when we write that, we just separate them with a comma. So that says negative infinity to positive 5. Now, the brackets on the outside are going to tell us whether it's included or not. Infinity is never included because it goes on forever and ever. It's not a point that you can actually reach. So any number that you give me, I can give you one more number, that's farther out. So you can never actually reach infinity, so it can never be included. So infinity is always a round bracket. Okay, and then at 5, 5 is not included. And the nice thing about this notation is that it shows you what type of notation we need. Okay, round bracket means not included, round bracket means not included. Okay, so it kind of looks like, it's kind of like a shorthand for the number line in this version. Okay, so I'm going to erase this. Okay, that was just there for comparison. All right, going on to the next one. Let's say that we've got x greater than 8. Okay, in set builder notation, x such that x greater than 8. And then on a number line, okay, we're looking at 8, and we want to be greater than, so that means that we're going to the right. Okay, so we shade all of that in, and it's not included here, so it's not going to be included on the number line. That means it's a round bracket, and again, it faces the direction of the shading. Okay, so a little bit hard to do with my pen there. There we go. Okay, and then in interval notation, we go from left to right. Okay, we don't have anything out here. It starts at 8, and it goes to positive infinity. Okay, so it starts at 8 and it goes to positive infinity. 8 is not included, and infinity is never included. Okay, let's try x less than or equal to 2. Okay, so this one's different, right? This one means all the numbers up to and including 2, because it's included. So in set builder notation, x such that x is less than or equal to 2. On the number line now, we're looking at 2. We want all the numbers that are less than. Okay, now we need a different notation. We need a different notation now that it's included. So instead of a round bracket, we have a square bracket. Okay, square bracket faces the direction. Now for comparison, you may have done this before with a closed dot. So you'd have had a closed dot for this. Okay, so it'd be a closed dot if it was included, and then remember up here it was an open dot for not included. So that's the equivalent. If you've done closed dot, open dot, this is the square bracket's the same as a closed dot. It means included. Okay, and then doing interval notation again, we're going to go from left to right. So we are shaded at negative infinity, so we're going to go negative infinity to 2. Okay, that's our interval, negative infinity to 2, never included at infinity. And this time we are included at 2, so we're going to have a square bracket. Okay, so when you look at these interval notations, it tells you exactly what your interval is. 8 to infinity not included, negative infinity to positive 2, and positive 2 is included. Okay, so all right, so we can also have x less than, oh, sorry, let's do a greater than. Let's say x greater than negative 3, x such that x is greater than negative 3 is what it would look like in set builder notation. And then we've got our number line. We're looking at negative 3 this time, and we want to be greater than, so we're going to go to the right. And negative 3 is included, so we're going to make that a square bracket. Okay, so now setting up the interval notation, we're going to go from left to right. We don't have anything at negative infinity. It starts at negative 3, and it goes through to positive infinity. Okay, so negative 3 to positive 3, infinity. It is included at negative 3, never included at infinity. Okay, so that's the basic idea for interval notation. Now notice you have to go left to right. If you write the interval infinity to 8, that makes absolutely no sense, okay, because you can't read this from right to left. It always goes smallest to biggest. So it has to go from left to right. Okay, this interval doesn't make any sense. And then we can also have a two-sided inequality. So let's say we've got like negative 3 is less than x is less than or equal to 9. Okay, so in set builder notation, x such that x is between 3 and 9. Okay, so there's a few different ways that you can read this. You can say negative 3 is less than x is less than or equal to 9. Usually we'll just say x is between negative 3 and 9, and you would say inclusive for the 9 because of the one there. Okay, so we're going from negative 3 to 9. We've got all of the numbers in between. So that's going to look like that. Now we need to decide included, not included. We're not included at negative 3, so that's going to be a round bracket. We are included at positive 9. That's going to be a square bracket. Okay, and then our interval is going to look exactly like this, with the brackets and everything. So we start from negative 3. We go to positive 9. We've got a round bracket at negative 3 and a square bracket at positive 9. Okay, so the interval notation is kind of shorthand for the number line. When in doubt, set up the number line, and then you should have the interval notation.